Module 2, Lesson 4, Interpreting and Computing Division of a Fraction by a Fraction, more models. So yesterday we started looking at fractions divided by fractions, but the fractions had the same denominator. Today we're going to take a look at situations where the denominators are not the same and some strategies we can use to approach that. So I can use fraction bars and area models to divide fractions by fractions when the fractions have different denominators. Fraction bars aren't really easy to show on a Google slide presentation, so we'll look at area models. But as we look at area models, we'll also look at number lines and tape diagrams. And of course, tape diagrams are a form of area model. And once again, we'll be looking at different denominators, so they won't have the same. I can show and explain the connection between visual models and the multiplication of fractions. So we are going to continue to see the relationship between multiplication and division. All right, so one of our strategies that we're going to use today as we divide fractions that have different denominators, we're going to make equivalent fractions. So we're going to do a little bit of scaling so that we can get the denominators to be the same. So we're looking for 3 equivalent fractions to 2/3. And if I were to think of this as equivalent ratios, I've got 2 and I've got 3. And right now I've got a value of 1 in each of the units, and that would be 2/3. If I switch this to a value of 2, then I would have 4/6. If I have a value of 3, then I would have 6/9. If I have a value of 4, I have 8/12. And of course, what my tape diagrams are helping me see here is the scaling process. I've got 2/3, and I multiplied each of the parts times 2, which would give me 4/6. And I've got 2/3, and I multiplied each of the parts by 3, which gave me 6/9. And I've got 2/3, and I multiplied each of the parts by 4, and I've got 8/12. So we build equivalent fractions by making equivalent ratios using scaling, multiplying the two parts by the same factor. And of course, this holds true with division. For example, on this second problem, we've got 10/12, and I can divide both of these parts by 2 and get 5/6. And of course, I could take 5/6 and multiply times 3, each of the parts by 3, and get 15/18. And I could take 5/6 and I could multiply each of the parts times 4, and I have 20/24. And of course, I could draw models to do this, but drawing out 10/12 is a whole lot more work than drawing out 2/3. Now, drawing 5/6 is a little more manageable. And once again, I can just plug in different values for the units. So now I have 5 to 6, 10 to 12, there's the 15 to 18, and I can keep repeating that process. All right, so now that we've made equivalent fractions and know that we're going to use that as one of our strategies today, let's take a look at a problem here. Molly has 1 3/8 cups of strawberries, and she needs 3/8 cups of strawberries to make 1 batch of muffins. And the question is, how many batches of muffins can Molly make? So we're trying to find how many groups of 3/8 are in 1 3/8. And that sounds to me like a measurement division problem. How many groups of a size can be formed? So I've got 1 3/8, and I need to take out some 3/8 and see what I've got going on here. Well, I'm going to set this up as a tape diagram. So there's 1 cup, And I'm going to need a second cup because she's got more than one cup. She's got 1 3/8. So here is my first whole cup. And here is a second whole cup. She doesn't have 2 whole cups, but if I'm going to have 3/8 of another cup, I need to have a cup to keep them in. And I need to make eighths because we're measuring in eighths. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I need to find where that 3/8 is. 1, 2, 3. Okay, so there's my 3/8. So I have 1 full cup right here, and I have 3/8 of a cup here, and I am going to make groups of 3/8. So let's see here. 1, 2, 3. There's a group of 3/8. There's one batch. 1, 2, 3. There's another batch. 1, 2, 3. There's another batch. And then I've got 2 pieces left over. So I know that I can make 3 whole batches. And I know that I'm putting 3 in each batch. And I've got 2 parts left over. So I'm pretty sure here that I would have 3 2/3 batches that Molly can make. So that is one way that I could approach this problem. Now, here's another way, kind of building off of something we did in lesson 3. I can count up my eighths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 eighths, and I want to make groups of 3/8. And I could write this in my unit form, 11 eighths divided by 3/8. And the eighths are going to cancel. They'll divide each other out, and so then I'm left with 11 divided by 3. And I'm kind of running out of room here, so I will squeeze it in the corner here. 3 times 3 gets me 9, and I've got 3 2/3. So the same number of batches that I found with my model. Now the last connection is the multiplication connection. 11 eighths divided by 3/8, and we've been playing with this multiplication connection here. We've been taking this divisor and we have been flipping it over so that our eighths will cancel, and I'm left with 11 divided by 3, which gives me 3 2/3. So I've now worked this problem 3 different ways to find out that Molly can make 3 2/3 batches of muffins. I've got a tape diagram going on. I have canceled my units, and I have played or experimented with the multiplication that we have been testing. All right, so Molly's friend Xavier, he's also got 1 1/8 cups of strawberries. And he needs 3/4 of a cup. So he can make some strawberry tarts. Tasty. And the question is, how many batches can he make? So once again, I'm hearing a measurement division problem. I need to know how many of these fit inside this. Now I'm already noticing that I don't have the same denominators. So when I set this up for a model, I've got my 1 cup, and I've got my 2nd cup. And so this is my 1 cup here, and here's another cup here. And I need to make 8 pieces because it says 1 1/8 cups. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And right here is my 1/8. And I need to put them into groups of 3/4. The problem is I don't see very naturally or very easily fourths. My brain is saying I could maybe try something like if I combine these two, they make 1/4. And if I combine these two, they make 1/4. And if I combine these two, they make 1/4. And if I combine these two, they make 1/4. And then over here, I've got my other 1/8, which winds up being not a fourth, but a half of a fourth. So I'm not sure that that's going to help me out very much. Although it's a good observation that I could combine some 1/8s to make some fourths. It might be easier if I answered the question, how many 1/8s are there in 3/4? If I've got 3/4 and I want that to become 1/8s, I can find that there are 6/8s in 3/4. And I can come over to my model here real fast, and I can see, going back here, here was a fourth, here was a fourth, and here was a fourth. I can see that I've got 6/8 in 3/4. So I have a model that actually shows me that 3/4 is equal to 6/8. And now, because everything's in 8ths, I can work this problem, 1 and 1/8 divided by 6/8. And now I've got pieces that are all the same size, so it makes my grouping a whole lot easier. So I can actually start counting out some groups of 6. 1, 2, 3, 4, 5, 6. So there is one batch of strawberry tarts. And I've got 1, 2, 3 more pieces. And I'm pretty sure that I have read this problem incorrectly. So I'm going to finish it here, and then I'm going to go back and do it a different way. I read this as 1 and 1/8 when it's actually 11/8. So that's going to totally change the problem. But I'm going to finish it this way so that we can kind of see how this plays out, and we can see that the procedure we're going to go through will actually work here. So we've got 1 and 1/8 divided by 6/8. And I've got one whole group of 6/4, and then I've got 3 pieces. So I've got one whole group, and my groups are groups of 6. So that'll be my denominator. And I've got 3 pieces left. So I could find out that Xavier can make 1 3/6 batches of strawberry tarts. Now, 1 and 1/8 is the same as 1, 2, 3, 4, 5, 6, 7, 8, 9/8. So I've got 9/8 divided by 6/8, and I could turn this into unit form. So my 9/8 divided by 6/8, and the 8s will cancel each other out, and I'm left with 9 divided by 6. And once again, I'll sneak this into the corner. 9 divided by 6. 1 times 6 is 6. I get 3. 1 and 3/6. So I've got 1 and 3/6 again. So this one came from model. This one came from using unit form. That leaves the multiplication approach here. So I've got 9/8, and I'm going to divide it by 6/8, and I'm going to do 9/8 times 8/6, so that my 8s will cancel out, and I've got 9/6, which once again turns into 1 and 3/6. Now, I'm pretty sure in your workbooks that yours says 11/8 cups of strawberries, so that's pretty poor reading on my part. So I'm going to quickly set this up and do this as 11/8. So I've got my 1, 2, 3, 4, 5, 6, 7. So I've got 1 cup. 1, 2, 3, 4, 5, 6, 7. There's a second cup. Here is my 8/8, and I've got 1, 2, 3 more. So there's my 3/8, and I've already figured out that 3/4 is equal to 6/8. So I'm making groups of 6. 1, 2, 3, 4, 5, 6. So there's a group of 6. And I've got 1, 2, 3, 4, 5. So I've got one whole group of 6. I'm making groups of 6, and I have 5 pieces. So Xavier could make 1 5/6 batches of strawberry tarts. I can set this up as my unit form, 11/8 divided by 6/8, and the 8s will cancel, and I've got 11 divided by 6, which will give me the 1 5/6 again. So now I've got 2 different forms here. I've done it with a model. I've done it with unit form, and that leaves my multiplication form, 11/8 divided by 6/8, and we're testing 11/8 multiplied by 8/6. The 8s will cancel, which will leave me with 11/6, which I have already figured out is the 1 5/6. All right, example 3. So we're now going to stretch our brains a little bit here. We've been focusing very heavily on measurement division, and I would like us to think of this as partitive division. And when we do partitive division here, we are thinking to ourselves, 6/8 is 2/8 of some number. So 6/8 is part of another number. And we're trying to find out what that number is. Now, we were really comfortable doing this with models. So I know that 6/8 is 2/8, so I'm going to need a hole here, and I'm going to need some 8s. 1, 2, 3, 4, 5, 6, 7. I've got some 8s, and this is my 8/8, and I know that 6/8 is equal to 2/8. So here's the 2/8, and that is equal to the 6/8. Because it says right here 6/8 is 2/8. They're equal to each other. So the 6/8 has been divided into 2 parts, and so I can see that each of my units is going to be equal to 3. And I can see that each of the units then will be equal to 3. And I can see that 6/8 is 2/8 of 24. Although my brain is screaming that I've done something wrong, I'm going to have to pause here and meditate on this for a second. Oh, of course. Of course. I am so silly. Two, three, four, five, six, 7. each of these is equal to 3/8. They're not equal to 3, they're equal to 3/8 because this isn't a 3, this is a 6/8. I'm glad my brain was turned on today so that I could catch that. And so then I can look and say, what do I have here? What is my total? Well, I've got 3/8 times 8. So 3, 6, 9, 12, 15, 18, 21, 24. And I can see that I have 24/8. And 24/8 is equal to 3. So 6/8 is 2/8 of 3. Well, let me put it this way, 24/8, which is equal to 3. Boy, that was almost a big mistake there. So it's important to make sure that we slow down and think about what's actually happening here. I just saw the 6 cut into 2 parts, but it's really 6/8 cut into 2 parts. So each of these units here is equal to 3/8. So thinking about this problem in a partitive way and thinking about it in kind of a unit form, I hope that's the right way to say that, I can see that I've got 2 units here. And these 2 units are equal to 6/8. And I'm going to take that 6/8 and I'm going to write it in a unit form. And so if I'm going to get the value of 1 unit, I'm going to divide by 2, and I will find that 1 unit is 3/8. And there are 8 units, so now I can scale this up. So I divided by 2 there, multiply by 8 here. So 8 units is equal to 3 times 8, which would give me 24/8. And 24/8 is equal to 3. 24/8, which is equal to 3. So thinking about this, and this is exactly what we did on the model here, we took the 2 units, these 2/8, and we said that they are equal, the 2/8 are equal to the 6/8 right here. And then we found the value of 1 unit, and we said that was 3/8. And then we counted up and said we have 8 of those, so 8 of our units is equal to 24/8. And 24/8 is equal to 3. I know partitive division feels a little bit weird when we look at it, but powerful way of looking at division and using division. All right, example 4. So we have 3/4 divided by 2/3. Now the first question I'd like to ask is this measurement or is this partitive? And the answer is it could be either of them. It could be 3/4 is 2/3 of a number, and it could be answering the question of how many 2/3 in 3/4. It all depends on the context, which we don't have. But we can do some logic thinking as we think about this. When we get the quotient for either of these problems, is the quotient going to be larger or greater or less than 1? Greater than 1 or less than 1? Well, With both of these, I can look at this and think about this and come up with an answer to this question of greater than 1 or less than 1. How many 2/3 and 3/4? Well, there's at least one 2/3 and 3/4, which means that I'm going to have a little bit of a remainder, so I can fit it in at least once, plus a bit more, which means my quotient, greater than 1, is going to be greater than 1. Three-fourths is 2/3 of some number. So 3/4 is only part of it, and I have to add some more. So I'm going to think here that that extra third to get to 3/3 is going to make 3/4 greater than 1. So I'm looking and thinking that the quotient is going to be greater than 1. Now, so that's kind of just a little logic exercise thinking about quotients before we get started. As we look at 3/4 divided by 2/3, how is this different than the problems in less than 3? And we should be noticing the denominators are not the same. So the question becomes, how can we approach this problem? Well, before we get too far here, I'd like to take a look here and just see what's happening. 3/4 is 2/3 of a number. So I have a model so that I can see kind of what's happening here. I've got my 2/3 up on the top here, and I can see that 3/4 is equal to that 2/3. And the question becomes then, well, what strategies can I employ to make this problem a little easier to work with? And we've talked about it before. Well, I could make some equivalent fractions out of this. So I can do some scaling here so that I can get the denominators to be the same. 12 will be a common denominator as I count up 3, 6, 9, 12, 4, 8, 12. 12 is the first common multiple of 3 and 4, so I want to scale my fractions here. 3/4, and I'd like to have a denominator of 12, so I multiplied times 3 multiplied by 3, and I've got 9/12. So 9/12, and I've got 2/3, and I want to scale that to be a 12, which means I multiplied it times 4, and 2 times 4 is 8. So I've got 9/12 divided by 8/12. So I can take my model now and I can adjust it to match. And I know I started with a tape diagram, but I'd like to look at this on a number line. So I've got 0 and I've got 1 here, and that's 12/12. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 12, 2, 12, 3, 12, 4, 12, 5, 12, 6, 12, 7, 12, 8, 12, 9, 12, 10, 12, and 11, 12. And I am counting up how many groups of 8/12 I can make. So here is 8/12, so I've got one group. And I don't have enough to make another group. And it's important we remember here that I've got how many 8/12 are in 9/12. I've only got 1/12 left over. I am putting them in groups of 8, which is my denominator then. And I have this one piece left over. So I can make 1 and 1/8 groups of 8/12 out of 9/12. And I could set it up as my unit form. So I've got 9 divided by 8, which 9 divided by 8 gives me 1 1/8. And I could play with the multiplication and I would get the same result. 9/12 times 12/8. 12ths will cancel, which will give me 9/8. And we've already done the division and know that that is 1 1/8. So in this particular problem, we had to make equivalent fractions for both of the denominators, not just one of the denominators. Other than that, the models all remain the same. We're counting up how many groups can we make. We're paying attention to how many we're putting in each group. Everything remains like it was. We just had to work with both of the fractions instead of one of the fractions. And we did take a moment and do a little bit of a logic exercise thinking there about the quotient. By the way, notice that the quotient was greater than 1 as predicted. All right, so we've got a whole bunch of practice problems here, and we are simply to find the quotient, and it would be, of course, great to do a model to justify the answer. It would be great to do these with all 3 of the different approaches that we have used so far, testing everything out and making sure that we are comfortable. So I've got 6/2, and I need to divide it by 3/4. I don't have common denominators. However, if I look for least common multiples, I see that 4 will make a good common denominator. So I'm going to take this 6/2, and I'm going to scale that to a denominator of 4. 2 times 2 is 4, 6 times 2 is 12. So I have 12/4 divided by 3/4. And if I put this in unit form, 12/4 divided by 3/4, I will have 4, because the fourths will cancel, and I am left with 12/3. So there are 4 3/4 in 6/2, so a quotient of 4. With a model, if I were to use a number line, I'm going to need to get up to 12/4 here. So 1 gives me 4/4, 2 gives me 8/4, and 3 gives me 12/4. So there's 4/4. Ooh, it'd be nice if I could make a little bit more of an effort to make those look kind of nice. There's 8/4. And now I have 12/4. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, and 12/4. And I need to put these into groups of 3. So 1, 2, 3, there's a group. 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 So I have 4 groups of 3/4, which is good because I already found 4 once before. Now I've done it as a model. And then we've got our 12/4. 12/4 divided by 3/4, and we've got this multiplication thing we've been experimenting with. And the fourths will cancel each other out, and I've got 12 divided by 3, 12 divided by 3, which gives me the 4. So I've now worked this problem 3 different ways. All right, let's take a look at exercise 2. 2/3 divided by 2/5. Well, I don't have the same denominator, so first thing that would be really useful is if I could just get the same denominator. So do a little multiple work here. 3, 6, 9, 12, 15, 18, 5, 10, 15. Aha! 15 will be my new denominator because it is the least common multiple. All right, 2/3, and I want to scale this to be 15ths, and 2/5, and I want to scale this to be 15ths. And multiply times 3, and I get 6/15. Multiply by 5, and I've got 10/15. So I've got 10/15 divided by 6/15. And the 15ths will cancel each other out. I've got 10 divided by 6. Which will leave me with 1 4/6 as a quotient, which I know you could simplify to be 1 2/3. If I were to set this up on a number line, I'm going to need some 15ths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. And it says that I have 10/15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is my 10/15. And I am supposed to make groups of 6/15. How many groups of 6 can I make? All right. 1, 2, 3, 4, 5, 6. Yay, a group of 6. And I've got 1, 2, 3, 4 pieces left. So I have one whole group of 6. So 6 is the size of my groups. And I have 4 left. So I have 1 4/6. We've got 10/15 divided by 6/15, and we've been doing our experimentation here, 10/15, and we're inverting, flipping over the divisor, and the 15ths will cancel each other out, and we're left with 10/6, which is 1 4/6. Very nice indeed. All right, taking a look at exercise 3, 7/8 divided by half. Once again, I don't have common denominators, but I know that 8 is a multiple of 2. So I can scale this half up to have a denominator of 8. Multiply it times 4, multiply it times 4. I've got 4/8, so I've got 7/8 divided by 4/8. The 8s will cancel, and I've got 7 divided by 4. And I've got 1 3/4 groups of 1/2 in 7/8. Looking at this as a model, I could tape diagram this, which is going to look very similar to a number line here. I am going to need 7/8 so that I can count up the number of halves that are in it. So I'll need 1, 2, 3, 4, 5, 6, 7. I've got my 8/8, and right here is my 7/8. And I know that I am making groups of 4/8. So I've got 1, 2, 3, 4. There's a group of 4. And I've got 1, 2, 3 left. So I made one whole group of 4, and I've got 3 pieces left, 1 3/4. So then I've got 7/8 divided by 4/8. And we're testing out our multiplication, and I've got 7/4, which I wound up with 7/4 right over here. And I got 1 3/4, so I know that this will be 1 3/4. All right, taking a look at exercise 4. 3/5 divided by 1/4. So I'm going to need common denominator 5, 10, 15, 20, 25, 4, 8, 12, 16, 20. Looks like 20 is the first denominator that they will have in common. So 3/5 and 1/4, and I need to scale to be 20ths. So the 4 will multiply times 5, and the 1 will multiply times 5. And the 5 will multiply times 4, and the 3 will multiply by 4. So I've got 12 20ths. 12 20ths. 20. I'm not sure how to spell that. And I'm dividing that by 5 20ths. I keep thinking there probably needs to be an E in there, but they're going to cancel out anyway. And that leaves me with 12 divided by 5. Oh, there'll be 2 5s. So that leaves me with 2 and 2/5. And I could draw a model of this with some 20ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19. It's a lot. All right, and it says that I've got 12 of them because it's 12 20ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, there's the 12 20ths. And I need to make groups of 5 20ths. 1, 2, 3, 4, 5. So there's a group. 1, 2, 3, 4, 5. So there's a second group. And here's my little leftovers. So I've got 2 whole groups of 5. And I have 2 pieces left over, 2 and 2/5. All right, 12 20ths divided by 5 20ths. And we were doing this multiplication thing, 12 20ths. So that the 20s will cancel out, and we've got 12 divided by 5, which we had right over here, and we got 2 and 2/5. All right, taking a look then at exercise 5. 5/4 divided by 1/3. All right, so they don't have the same denominator, but I've seen the 4s and the 3s enough today that I'm pretty sure the denominator is going to be 12. 5/4, scale that to 12, times 3, 15 twelfths. And 1/3, scale that to 12, multiply times 4, multiply times 4. I've got 15 twelfths divided by 4 twelfths. 15 twelfths divided by 4 twelfths. The twelfths will cancel. I've got 15 divided by 4. So I'm predicting a quotient of 3 3/4. 15 twelfths divided by 4 twelfths, and set that up as our multiplication, 15 twelfths times 12 fourths. So the twelfths will cancel just like we did over here. And I've got 15 fourths, which will divide to be 3 3/4. And if I were to put this on a number line, here's 12 twelfths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here's 13, 14, 15. So here's 15 twelfths. And I am making groups of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that leaves me with these 3 little pieces left over. I made 3 whole groups of 4. and I had 3 parts left over, 3 and 3/4. So I'd like you to notice that on almost all of these problems, I went for a measurement division interpretation. Much easier to think about in terms of the models. However, it's important that we don't discount the power of the partitive division. All right, so when dividing fractions, is it possible to get a whole number quotient? So when I have a fraction divided by a fraction, can I get a whole number as the answer? And yes, it is possible to get a whole number quotient when dividing fractions. When the dividend is larger than the divisor, the quotient will be greater than 1. When the dividend, 2/3 divided by 1/4, I am going to get a quotient that is greater than 1. When the dividend is greater than the divisor, I will get a quotient greater than 1. So I can get some mixed numbers in there. I can even get some whole numbers. 3/4 divided by 1/4, dividend greater than the divisor, the quotient is greater than 1, and on top of that, it is a whole number with no remainder. When dividing fractions, is it possible to get a quotient that is larger than the dividend? So I've got a dividend of 2/3, and I want to divide it by some number, and I want to get a quotient that is going to be greater than 2/3. Now, I hope that we just saw in the last example that you can look and say 2/3 divided by 1/3 is 2. The quotient is larger than the dividend. So it is absolutely positively possible to get quotients that are larger than the dividend. And this addresses the misconception that many students have that when you have a number and you divide, that you're going to get a smaller quotient than the dividend. Division doesn't really make things smaller. When you are asked to divide two fractions with different denominators, what is one possible way to solve? Well, we looked at it. Find a common denominator, and we can go from there. All right, looking at the I can statements, I can use fraction bars and area models, and didn't look so much at the fraction bars, but definitely looked at the area models, tape diagrams, and number lines to divide fractions by fractions, and they didn't have the same denominator with different denominators. And I can show and explain the connection between visual models and the multiplication of fractions. So we continue to look and say, how does multiplication work with these division problems? So we are 4 lessons into Module 2, and I hope that you can see and feel that we are slowly layering on these concepts, that we're trying to go just a little bit deeper and a little more thoughtful in each one of the lessons. It can be tedious to do these models and to think about these things, but the goal here is a deep conceptual understanding of fractions and of division. So stick with it. Make sure you complete your problem set. If you've got questions, make sure you talk to your teacher.